You ever update an app, all excited for the cool new features, and then it's just worse, slower, buggier, or maybe that one feature you actually use is totally broken now? It's one of the great paradoxes of our digital lives, right? Updates are supposed to make things better, but sometimes they do the exact opposite. Today, we're going to dig into why good software goes bad.
Oh, you know the feeling. You hit that update button, expecting a slick new experience, and instead, your once zippy application starts moving at a snail's pace. I promise, it's not just you. This is a super common experience, and it's usually the first sign that something deeper is wrong under the hood.
And look, this isn't just us griping. As Science Daily points out, it's a very real and studied problem in computer science. These kinds of bugs even have a name. They're called performance regressions, and they are a massive headache for everyone, from us, the users, to the developers who are scrambling to fix them. So let's play doctor and get a proper diagnosis.
Right. Just like a doctor trying to figure out what's wrong, we need to put a name to these problems before we can even think about fixing them. And in the world of software, two of the usual suspects behind these digital meltdowns are software regression and environment drift. Let's break down what those actually mean.
So first up, we've got software regression, and honestly, it's pretty much what it sounds like. The software regresses. It takes a step backward. A feature that was working perfectly fine yesterday suddenly breaks after an update. Or, like we just talked about, the whole app gets sluggish. It's the digital equivalent of fixing a leaky faucet in the kitchen, only to find you've somehow caused a pipe to burst in the bathroom.
Okay, our second big problem is something called environment drift. The best way to think about this is like a recipe. Developers write a super precise recipe, the code, that tells the system exactly how to run. But over time, people make tiny little manual changes, maybe a quick fix here or a failed update there, and the actual kitchen, that's the live system, starts to diverge from the original recipe. Little by little, it drifts away from how it was designed, and that's when things get really unpredictable. And you know, this drift thing isn't just one simple problem. It happens in layers. At the very bottom, you've got infrastructure drift. Think of a server getting a manual security patch that nobody writes down. Then, in the middle, there's configuration drift. This could be as simple as an engineer changing a password for a quick test and then forgetting to change it back. And at the very top, you have application drift, where different bits of code that need to talk to each other fall out of sync. Every single layer of drift makes the entire system more and more fragile. So when everything hits the fan, how do developers actually respond? I mean, when a system that millions of people are using goes down, they have to act fast. So let's take a look inside the first aid kit they use to stop the bleeding and get things working again.
You've probably heard these terms flying around, right? Hot fix, patch, bug fix. But what's the deal? They might sound like they're all the same thing, but in the trenches of software development, they are very different tools for very different jobs.
This chart lays it out really nicely. A hot fix is like emergency surgery. It's rushed out the door to fix a massive, critical problem, like a security hole. But because it's so rushed, it's also high risk. A patch, on the other hand, is more like a scheduled checkup. It bundles a bunch of fixes together and goes through proper testing before it's released. And a bug fix? Well, that's just the specific line of code that solves the problem. It's the medicine that gets delivered inside either a hot fix or a patch. Okay, so treating symptoms and putting out fires is one thing, but the best medicine is, not getting sick in the first place. So let's shift gears from just reacting to problems to the proactive strategies that keep software healthy from the get-go.
And the absolute cornerstone of prevention is something called regression testing. You can think of it like a full-body health scan for the code. Anytime a developer makes a change, a whole suite of automated tests runs to make sure that nothing that used to work has suddenly broken. It's a safety net, and it's crucial. It lets developers build new stuff with confidence, knowing that if they accidentally trip over an old wire, the tests will scream and shout before that broken code ever gets to you.
Now, to fight that environment drift we were talking about, developers deploy what are basically automated watchdogs. These are little scripts that are constantly running, constantly checking the live system and comparing it to that original recipe. The moment anything drifts, a setting gets tweaked, a file is changed, these watchdogs start barking and an alarm goes off. It's all about catching those tiny changes before they snowball into a huge problem.
So the overall game plan for preventing drift really comes down to 4 big ideas. 1. Automate everything you possibly can, so there's no room for human error. 2. Lock down access, so people can't just go in and make manual changes on a whim. 3. Make sure all your environments, from testing to the real thing, are as identical as possible. And 4, like we just saw, you monitor everything all the time,
so you can catch drift the second it happens.
So, all these issues, regressions, drift, all the fixes, they're really just symptoms of a much deeper, almost philosophical concept that every single software company has to deal with. And that concept is debt. This is what's known as technical debt. It's this idea that taking a shortcut today, choosing the quick and dirty solution instead of the right one, is like taking out a loan. You get what you want faster, but you're going to have to pay that loan back later, with interest in the form of extra work and headaches. And why do teams do this? Well, the pressure is real. Tight deadlines, trying to beat a competitor to market, so they knowingly take on this debt, always telling themselves they'll go back and fix it later.
There's this legendary quote from Nintendo's Shigeru Miyamoto that just perfectly captures this whole idea. Rushing a product out the door might feel like a win in the short term, but if it's built on a shaky foundation of technical debt, those flaws can haunt it forever. Taking the time to build it right, to pay down that debt as you go, leads to something that's actually solid and reliable in the long run.
So the next time your favorite app starts acting up after an update, just take a second to think about the incredible complexity hidden just beneath the surface. Think about the shortcuts that were probably taken, the compromises that were made, and all of that invisible debt that's now being paid back, one frustrating little glitch at a time.